Hello and welcome back to Random Topics with Jack. If you tuned into our last episode, you know we explored the fascinating journey of PC hardware evolution. Today we're continuing the two-part series by diving into the world of operating systems, the critical software that powers our devices and shapes our digital experiences. From the earliest command line interfaces to the sleek graphical environments we use today, operating systems have undergone significant transformations. They serve as the backbone of our computing experience, managing hardware resources and providing a platform for applications to run. In this episode, we'll take a closer look at the three major players in the operating system landscape: Microsoft with their Windows operating system, Apple with macOS, and various Linux distributions which are open source. We'll discuss their histories, key features, and the unique advantages and disadvantages of each. We'll also compare them to understand how they fit into various computing environments. So whether you're a Windows warrior, a Mac enthusiast, or a Linux lover, get ready for an insightful exploration onto the world of operating systems. Let's get started. So to kick things off, let's clarify what an operating system, or OS, actually is. An OS is a collection of software that manages computer hardware and software resources, providing essential services for computer programs. In simpler terms, it acts as an intermediary between users and the computer hardware, enabling interaction and functionality. The key functions of operating systems are resource management. So the OS is responsible for managing the hardware components of a computer, including the CPU, memory, storage devices, and input-output devices. It allocates resources efficiently, ensuring that each application receives the necessary resources to function effectively without conflicts. User interface. The operating system provides a user interface, which can be either command line based or graphical. This interface allows users to interact with the computer and execute commands. A good UI enhances the user experience by making it intuitive and accessible. File management. The OS manages files on storage devices, providing a system for organizing, storing, retrieving, and protecting data. It handles file permissions and ensures data integrity, allowing users to access their information securely. Task management. The operating system oversees multiple processes running simultaneously, allowing users to run several applications at once. It manages the scheduling of tasks and ensures that the CPU efficiently executes processes without resource contention. Security and access control. Operating systems implement security measures to protect the computer and its data. This includes user authentication, access control to files and resources, and protection against malware. Communication between software and hardware. The OS provides a set of services and APIs, also known as application programming interfaces, that allow applications to communicate with the hardware. This allows developers to create software without needing to manage hardware directly, streamlining the development process. The evolution of operating systems is a fascinating journey that mirrors the development of personal computing itself, from the early days of single-user systems that required manual command input to the sophisticated multi-user environments we have today. Operating systems have continually adapted to meet the needs of users and advancements in technology. The journey of operating systems is a testament to the rapid advancement of technology and the increasing complexity of user needs. Let's explore the key milestones in the evolution of operating systems. So first we'll look between the 1950s and the 1960s, where we had batch processing systems. These were the earliest OSs that were designed for mainframe computers, where jobs were processed in batches. Users submitted jobs on punch cards and the OS would execute them sequentially. These and monitor programs. These systems managed the execution of jobs, allocating resources, and provided basic error handling. Now, between the 60s and 70s, we've seen the introduction of time-sharing systems. The concept of time-sharing allowed multiple users to access a single computer simultaneously. This was a significant shift towards interactive computing. And we also seen the development of Multics project, Multiplex Information and Computing Service, was introduced. It introduced many foundational concepts, including hierarchy file systems and user provisions. Between the 70s and 80s, we had the birth of personal computing. We had the CP-M, or Control Program for Microcomputers. One of the first operating systems for PCs was CP-M, and it allowed users to run software on microcomputers. This paved the way for DOS, which brings us on to MS-DOS, which is Microsoft Disk Operating System, which became the dominant OS for personal computers in the early 80s, providing a command line interface and basic file management capabilities. In the 80s and 90s, we saw the introduction of GUIs, the graphical user interface, which revolutionized operating systems, making them more user-friendly. Apple's Macintosh OS and Microsoft Windows were pivotal in this movement. We also seen the rise of Unix and its variants. Unix became a foundational operating system for servers and workstations, influencing many modern OS designs. Its multi-user capabilities and robustness made it popular in academic and enterprise environments. Now we look at modern operating systems. Microsoft Windows transitioned from Windows 3.x to Windows NT, introducing improved stability and security features. Windows XP and later versions brought significant enhancements in user experience. Linux, the open source movement, led to the creation of Linux, which has become a popular alternative for servers, desktops, and embedded systems. Its flexibility and community-driven development model have contributed to widespread adoption. Notable distributions or distros of Linux include Ubuntu, which is known for its user-friendly interface, making it very accessible for beginners. Fedora, which is focused on cutting-edge features and technologies. Debian, which is renowned for its stability and extensive package repository. And CentOS, a popular choice for servers based on Red Hat Enterprise Linux. We also see mobile operating systems with the rise of smartphones. That has brought about new operating systems like Android and iOS, which focus on touch interfaces and mobile applications, significantly changing how users interact with the technology. Current trends and some future directions that we'll see computer OSs going in include cloud computing, which is where operating systems are integrated with cloud services, enabling remote access to applications and data, as well as virtualization. Technologies like virtual machines and containers reshape how operating systems manage resources, allowing multiple OS instances to run on a single hardware platform. So yeah, operating systems are complex systems that manage hardware and software resources, providing essential services for computer programs. At the core of an operating system is the kernel, which serves as the core component that manages communication between hardware and software. It is responsible for resource management, including the CPU, memory, and devices, as well as process management, which covers the creation, scheduling, and termination of processes. This kernel also facilitates system calls for user programs, allowing them to interact with the system. The user interface is another critical component of operating systems, allowing users to interact with the system. The two main types of user interfaces are CLI or command line interface, which enables users to execute text commands such as the terminal in Linux or command line in Windows, and the graphical user interface, which provides a visual way to interact with the Windows icons and menus, like the Windows desktop or GNOME GMOME. The primary purpose of the user interface is to facilitate user interaction with the system, making it easier to execute commands and manage files. The file system is essential for organizing and managing data stored on storage devices. It handles file creation, deletion, and manipulation, manages a directory structure within folders and subfolders, and enforces access control and permissions to ensure data security. In terms of process management, this component is responsible for handling processes within the system. It oversees the creation and termination of processes, schedules them for CPU time, and implements inter-process communication or ICP mechanisms to allow different processes to communicate with each other. Another important aspect is memory management, which ensures the optimal use of RAM and manages data storage. This component is responsible for allocating and deallocating memory to processes, handling page replacement and swapping, and managing virtual memory, which extends the capabilities of RAM. To enable communication between the operating system and hardware devices, device drivers play a crucial role. These specialized programs provide an interface that allows the OS to communicate with various hardware, enabling functionalities such as printing, scanning, and accessing storage devices. Lastly, security and access control are vital for protecting system resources and data from unauthorized access. This includes mechanisms for user authentication, like passwords and biometrics, file permissions, access control lists, and encryptions to safeguard data. In the next section, we will explore three major operating systems: Windows, macOS, and Linux. Each of these operating systems has its own unique history, features, user interfaces, advantages, and disadvantages. So we'll start with Windows. Windows was originally released as Windows 1.0 in 1985. It served as a graphical extension for MS-DOS, enabling users to interact with their computers using graphical elements rather than just text commands. Over the years, Windows has evolved through numerous major versions, including Windows 95, 98, XP Vista, 7, 8, 10, and the latest Windows 11, which was introduced in 2021. This evolution reflects the continuous advancements in technology and user expectations. Windows is well known for its user-friendly interface, which features a taskbar, start menu, and desktop icons. This design allows the users to navigate their systems easily. One of Windows' significant advantages is its compatibility with a vast range of software applications, from productivity tools to high-end games. The File Explorer makes file management straightforward, enabling users to organize and access their files efficiently. The advantages of Windows include its intuitive interface, extensive software support, and strong gaming capabilities. However, it also has its drawbacks, such as vulnerability to malware and viruses, a requirement for regular updates that can sometimes disrupt workflow, and higher system resource demands compared to some alternatives. Now we'll look at Mac. macOS, originally introduced as OS X in 2001, represented a major transition for Apple as it shifted from the classic Mac OS to a more modern Unix-based system. This change allowed for enhanced performance and stability. Over the years, macOS has undergone several significant updates, with notable releases such as Mac OS X Leopard, which introduced features like Time Machine, and Mac OS Yosemite, which brought a refreshed design. The latest version, Mac OS Ventura, was released in 2022, continuing the trend of innovation and user-focused enhancements. macOS is renowned for its sleek and minimalist design, which prioritizes user experience. The operating system features a user-friendly interface, characterized by the dock for quick access to applications, and the Finder for file navigation and management. One of macOS's standout attributes is its seamless integration with other Apple products and services, such as iCloud, allowing users to synchronize files and settings across devices effortlessly. Furthermore, macOS comes equipped with a suite of high-quality built-in applications, including Safari for web browsing, Mail for email, and iMovie for video editing, catering to a variety of user needs. The advantages of macOS include its excellent performance and stability. Users often praise its strong security features, which help protect against malware and viruses. Additionally, the overall design and user experience are frequently regarded as superior, making it a favorite among creative professionals. However, macOS does also have its drawbacks. The software availability is relatively limited compared to Windows, particularly for niche applications and certain gaming titles. Furthermore, Mac hardware tends to come at a premium price, and gaming support is generally less robust than on Windows platforms. So now we'll look at the third OS, which will be a bit of a more difficult one to cover because of so many different offshoots. But we're going to try and cover as much as we can, but still keep it fairly succinct. And that's Linux, which was created by Linus Torvalds in 1991 as a free and open source alternative to proprietary operating systems. Its development began with the release of the Linux kernel, which is the core component of the operating system. Over the years, various distributions or distros have emerged, each tailored to suit different needs. The popular ones we've already spoke about: Ubuntu, Fedora, Debian, and CentOS. The open source nature of Linux has fostered a vast community of developers and users, contributing to its continual evolution and improvement. One of the most significant features of Linux is its customizability. Users can tailor the operating system to fit their specific needs, from the kernel level to the UI. Linux offers various desktop environments such as GNOME, KDE, and XFCE, allowing users to choose the look and feel that best suits them. Additionally, Linux is known for its robust performance and stability, making it a popular choice for server and professional workstations. The command line interface is powerful and allows advanced users to perform complex tasks efficiently. Now, the biggest advantage of Linux is its cost effectiveness, as it is free to download and use, and its strong emphasis on security and privacy, which is appealing to many users. The active community support provides users with a wealth of resources and documentation to help troubleshoot issues. Furthermore, Linux is often more efficient with system resources, which can lead to improved performance on older hardware. However, Linux does have some downsides. The learning curve could be steep for users transitioning from more graphical operating systems like Windows or macOS. Additionally, some software applications, particularly commercial software, may not be available natively on Linux, which can limit the options for certain users. A notable workaround for this limitation is an application called Wine, which allows users to run Windows applications on Linux. While not a perfect solution, it does open up some options for Linux users, enhancing their software availability. Now, the target user base for each operating system varies significantly based on their features and intended use. Windows primarily caters to a broad audience, including everyday consumers, gamers, and business professionals, due to its extensive software compatibility and user-friendly interface. It's the dominant choice in corporate environments and educational institutions where familiarity and application support are crucial. macOS, on the other hand, appeals to creative professionals such as graphic designers, video editors, and musicians, who benefit from its seamless integration with creative software and hardware. Its premium design and user experience attract users who appreciate aesthetics and functionality. Linux attracts a more niche audience, including developers, system admins, and tech enthusiasts who value customization, control, and open source software. Its use in server environments and among users who prioritize security and privacy further defines its user base. Overall, each operating system serves distinct communities with unique needs and preferences. However, it is important to note that these categorizations are not hard and fast rules. Personal preference and familiarity with an operating system will guide users' choices, even if they're not that target audience. Operating systems play a crucial role in the functionality and management of various computing environments. In personal computing, operating systems such as Windows, Mac, and Linux provide user-friendly interfaces that enable individuals to interact with the computers easily. They facilitate software compatibility, allowing users to run a wide range of applications, from productivity tools to games, thereby enhancing their personal productivity and entertainment. Additionally, OSes manage hardware resources, ensuring that peripherals like printers, cameras, and external drives work seamlessly with the computer. Security is another essential aspect, as operating systems provide features such as user authentication, firewalls, and regular updates to protect against malware. In the realm of servers and enterprise use, server operating systems, Windows Server, and various Linux distributions are optimized for handling multiple processes and managing resources efficiently to serve numerous users simultaneously. They support virtualization technologies that allow multiple virtual servers to run on a single physical server, optimizing resource utilization and reducing costs. These operating systems are designed for high reliability and security, featuring robust access controls, data redundancy, and backup solutions to ensure continuous operation. Furthermore, they facilitate networking capabilities, enabling servers to communicate and share resources within enterprise environments. When it comes to mobile devices and embedded systems, mobile operating systems like Android and iOS are specifically designed for touch-based interactions, providing intuitive interfaces for users on smartphones and tablets. They're optimized for power efficiency to extend battery life, which is crucial for mobile devices. Embedded systems often utilize specialized operating systems such as RTOS or real-time operating systems, which ensure reliable performance under specific constraints found in appliances, vehicles, and IoT devices. Moreover, mobile operating systems support vast ecosystems of applications, enhancing functionality and providing users with a plethora of choices for customization. As tech continues to evolve, the landscape of operating systems is set to change significantly. One of the most prominent trends is the rise of emerging technologies such as cloud computing and virtualization, as we covered earlier. But we'll dive a bit deeper into it now. So cloud computing allows users to access resources and applications over the internet, leading to the development of operating systems that are increasingly focused on seamless integration with cloud services. This trend is driving the creation of lightweight OSs that prioritize connectivity and collaboration, enabling users to access their data and applications from any device, anywhere. And virtualization is another crucial trend influencing the future of OSs. As organizations seek to optimize their IT infrastructure, virtualization technologies are becoming increasingly popular. This allows multiple operating systems to run on a single physical machine, improving resource utilization and providing flexibility in deploying applications. OSs are evolving to support virtualization better, offering features that enhance performance, security, and management capabilities in virtualized environments. Looking ahead, predictions for the future of OS development suggest a shift towards more modular and adaptable systems. Developers are likely to focus on creating OSs that can easily integrate with various hardware and software environments, accommodating the diverse needs of users. Additionally, there's a growing emphasis on security, with future operating systems extended to incorporate advanced security features from the ground up, addressing the increasing threats in the digital landscape. Furthermore, the rise of IoT, or Internet of Things devices, will push the development of specialized OSs that cater to unique requirements of connected users. These OSs will need to be lightweight, efficient, and capable of operating within constrained environments while maintaining robust security protocols. In summary, as we move forward, the future of OSs will likely be characterized by enhanced integration with cloud services, increased support for virtualization, and a focus on security and adaptability. These trends will shape the way users interact with technology and redefine the capabilities of operating systems in various applications. In this episode, we've explored the multifaceted world of operating systems, delving into the roles across various environments from personal computing to enterprise servers and mobile devices. We discussed the future trends in OS development, highlighting the impact of emerging technologies such as cloud computing and virtualization, as well as predictions for more adaptable and secure systems. So as we finish off there, please join us for the next episode as we embark on an epic journey through the timeline of the Final Fantasy franchise, a tale that spans generations and realms. Get ready to level up your knowledge. And until next time, keep questioning and exploring.